Every time you move through the world, walk through a room, drive down a street, or step into a new city, your brain performs a quiet miracle. Without a map, without coordinates, it knows exactly where you are and where you're going. This isn't memory, and it isn't luck. It's an ancient navigation system built into your biology, an invisible compass made of cells. Neuroscientists call them grid cells. The hidden map deep inside your brain, near the hippocampus, lies a small region called the entorhinal cortex. It doesn't look like much, a thin layer of tissue tucked away in the folds of your temporal lobe. But inside that tissue lies one of the brain's most elegant codes, a geometric pattern that lets you understand space itself. In 2005, Norwegian scientists May-Britt and Edvard Moser were studying rats exploring a simple square box. They placed electrodes into the animal's entorhinal cortex and watched which neurons fired as the rats moved. At first, the data looked random, just dots on a map dot, but when they plotted every firing point together, a beautiful pattern emerged. The dots connected into perfect hexagons, repeating like a honeycomb across space. Each neuron fired only when the rat stood on certain invisible points of that hexagonal grid. Together, thousands of these neurons formed an internal coordinate system, an invisible lattice overlaying the world. The Mosers had discovered something extraordinary, the brain's internal GPS. The mathematics of motion. Every time you move, your brain updates your position within that lattice. It's like walking across a sheet of graph paper that only you can see. Each step shifts your position slightly, and your neurons update your coordinates in real time. Alongside grid cells are place cells, discovered earlier by John O'Keefe. Place cells act like pins on a map, marking specific locations: the bed, the door, the corner of the room. Grid cells, meanwhile, provide the map structure, its longitude and latitude lines. Together, they let you know where you are and how to arrive somewhere else. This pairing is so precise that even in total darkness, when vision and landmarks disappear, your brain can still estimate your location simply by tracking your movements. It counts steps, measures direction, and integrates distance. Scientists refer to this process as path integration, and your neurons perform it effortlessly. Why hexagons? You might wonder, why hexagons? Why not squares, circles, or random clusters? Nature loves efficiency, and hexagons are the most efficient way to tile a plane. They cover space completely with equal distances between centers, no overlaps, no gaps. Bees use them in honeycombs, crystals use them in molecular lattices. Your brain uses them to map the world. This shape allows the brain to represent large areas of space using fewer neurons and less energy. In other words, this represents the geometry of perfection, a pattern that balances simplicity with precision. The fact that your mind uses the same geometry as honeycombs and snowflakes is a quiet reminder. Evolution discovered the most elegant way to make sense of space. Humans and the internal compass. For a long time, scientists weren't sure if humans shared this same mechanism. After all, recording from single neurons in people is much harder than in animals. But in 2010, brain imaging studies revealed it. When people navigated virtual mazes, specific regions of the entorhinal cortex activated in a hexagonal pattern. Even in imagined navigation, when volunteers only visualized walking through a space, the same pattern appeared. That means your grid cells fire not only when you move through real space but also when you move through mental space. When you recall your childhood home or plan tomorrow's route, your internal map comes alive again. Your imagination literally walks through coordinates. When the map fails, this elegant system doesn't always stay intact. One of the earliest signs of Alzheimer's disease is spatial disorientation, getting lost in familiar places or forgetting how to navigate home. Scientists now believe that this breakdown of grid cells in the entorhinal cortex occurs long before memory loss becomes obvious. Without a stable grid, the brain loses its spatial anchor. It's not just that memories fade, the framework that organizes them collapses. Every memory is tagged with a where and a when. When you lose that spatial tag, the story of your life starts to fall apart. Understanding grid cells may one day help doctors detect Alzheimer's earlier, long before major symptoms appear. The brain is a living geometry. If you could watch your grid cells fire in real time, you'd see waves of activation rippling through your brain in rhythmic patterns. Each wave corresponds to your position, like a silent sonar ping. This beat matches the theta brain waves, which are waves that are related to memory and learning. In this way, navigation and memory share the same beat. When you explore a new place, your brain doesn't just record the experience, it composes it, blending rhythm, geometry, and memory into a mental song of location. That's why some neuroscientists say, your brain doesn't only remember places, it plays them. The everyday miracle of knowing where you are. We take orientation for granted. You stand up, turn left, and walk straight to the kitchen. Simple, right? But beneath that simple act lies an immense calculation, billions of neurons communicating in perfect harmony, constantly updating a 3D coordinate of you in the world. Your brain uses information from your eyes, inner ear, muscles, and tiny grid cells to keep you in line. The fact that you don't feel that computation proves how well it works. Every motion you make is a quiet triumph of biological math. The deeper meaning of here, the word here feels ordinary, but it's deeply profound. When you say, I am here, you're describing not just a point in space but the outcome of countless neural calculations. Your sense of being, your awareness of self, depends on that internal coordinate system. Without it, here and there blur together, and the mind loses its anchor in the physical world. In that sense, grid cells help define the boundary of the self. They don't just tell you where your body is, they also help shape your sense of self. Some scientists even suggest that the same mathematical patterns that code for physical space might also help organize abstract thought, like mapping ideas, memories, or social relationships in mental space. So the same system that enables you to locate your house may also assist you in discovering meaning. From cells to consciousness. When May-Britt and Edvard Moser first discovered grid cells, they were looking for a navigation system. What they uncovered was something larger, a universal principle. They discovered that the brain employs geometry to comprehend the world. They discovered that thought, memory, and movement are distinct manifestations of the same pattern. It is possible that consciousness itself, the feeling of moving through time and the sense of continuity in your identity, is partly built on this spatial code. You are a pattern moving across a pattern. A traveler walking through a living map. Closing reflection. Next time you stroll through your neighborhood, pause for a moment. Notice how effortlessly you know where you're going. You rely solely on your intuition, without the use of a phone or GPS. That intuition is billions of years old. It guided the first creatures across ancient oceans. It helped our ancestors return home through forests and deserts. And today, it guides you through the corridors of memory, imagination, and thought. Your grid cells are silent architects, drawing the blueprint of your world, one hexagon at a time. They are the hidden geometry behind every step you take, every place you remember, and every moment you say, I am here.